Our next speaker is Tina Grotzer, who's going to explain how we reason and how we don't. Did I get that right? Sort of?
Basically.
All right.
It's on there. Hi, folks. My name is Tina Grotzer, and I'm honored to be here. I am a cognitive scientist and science educator, and I'm on the faculty here at the Graduate School of Education. I'm just trying to find a spot to put that. Let's put it there. All right. And today, what I want to talk with you about has to do with the ways in which we reason about causal complexity and how that impacts our ability to really think about our world. I'm going to talk a little bit about some of the features of the problem space and also some of the challenges given how the human mind works. I'll also talk a little bit about some of the things that we're doing to help reasoners overcome the cognitive challenges and to help them think about how to reason more effectively. I think if, when radical reorganization is not possible, there are these other things that we can do along the way. And Frederick talked about sort of our limited awareness. I'm going to kind of sketch that out and talk about how we are limited in our awareness. I'm going to talk about social incentive structures as well, but I think more on the level of nudges than, sort of large-scale enterprises, and talk a little bit about what we're doing in K-12 when you can take the long view. One of the puzzles about education, about climate change, of course, is that taking the long view feels harder and harder every day. But yet we need to bring the next generation along. So, see if that works. We know we need to think about these things. It's becoming increasingly obvious to us. My colleague over at the medical school, Atul Gawande, talks about wicked problems, and I agree with Daniel that they're not as intractable as he might say, and they're not necessarily so unique. There are aspects and features of them that are similar and that we can learn to reason about. I would add that complexity, however, in most of K-12 education tends to get reduced. We simplify things for kids. We don't help them to see the beauty in complexity. And part of the reason that complexity presents us with so many wicked problems is that we don't know how to think well about it. Richard Feynman, the famous physicist, said, if we want to understand nature, we must understand the language in which she speaks to us. And I think we really struggle with that. Not our fault. I would say that our human cognitive architecture is not particularly well adapted for any of these tasks: perceiving, attending to, or reasoning about causal complexity. And we're pretty much evolved that way. So what does that mean? So for, 30 some odd years, since the late 1980s, I have been studying some of the default patterns that people engage in when reasoning about complexity. And we simplify things as a matter often of necessity to move through our everyday lives. If we stopped to take in all the stimulation coming at us every day, we wouldn't have gotten here this morning, right? So we filter, and we necessarily filter. But that unfortunately leads to certain kinds of assumptions about how things work that don't reflect the complexity of our world. So this is a set that is very well studied. There's significant research in cognitive science to support that we tend to simplify towards the, I guess that's your left side, yes, my right side, of the assumption and not recognize the more complex versions. I'm only going to talk about a few of them today, and ones that apply to climate change. This is a book that I've written that goes into detail on all of them, and gives a lot of examples for educators and people who want to apply them. So that's a place to look for more information. It's also shameless advertising.
And on sale at the book table.
Okay, all right. So cognitive scientists think about how we discern causation, and they they say that we're causal Bayesians, okay? The field says we look at instances of correlation, covariation. This happens, then that happens. This happens, then that happens. We notice patterns, we see patterns, we pay attention to patterns. Sometimes we intervene on those patterns, the controlled study, the gold standard that people look for. We often look for mechanisms. So if we go to a certain restaurant and suddenly we notice, oh, I feel ill, and you realize you felt sick last time you were at that restaurant, you then start to think about what could it be? Food poisoning, sushi restaurant, maybe something else going on. You start to look for the mechanism that explains it. And another way that we learn about causation is through testimony, through the things that people tell us. So with these 3 tools in our causal reasoning repertoire, I'm going to lead you through what makes some of our causal reasoning about climate change so problematic. So in the case of spatial complexity, spatial gaps often exist between causes and effects, so we don't see that covariation relationship. It's not obvious to us. And even if we did see it, it would be really hard to keep it in mind. So how many of you drove a car in the last few days? Okay. How many of you thought about polar bears before you got into the car? No, we're not going to do that. That's just not something that is on our mind, right? So researchers in cognitive science talk about action at a distance when cause and effect are separated. We study, in my lab, we study action at an attentional distance. What happens when the causes and the effects are in different attentional frames for various reasons? So what I want to share with you, all right, so let me go through this first and then I'll share a little example of how this comes into play. So if the cause and the effect are in separate attentional frames, you don't see the covariation relationship. It's not available to you. If you don't know that there's a covariation relationship, you are highly unlikely to look for a mechanism. And unfortunately, we often don't listen to testimony. Scientists, when in politics, when we try to be heard and we can't help people pay attention to these 2, they often don't trust that. So here's a nudge. This is about action at an attentional distance. You are walking down the street, you see them all over Boston and Cambridge. This is a reminder that this drain here connects to that river over there. Cause and effect relationship, just nudging you to think a little bit differently than you might. I'm going to show you an example from, some of you may know this, it's a car commercial. They want you to think about what's beyond. Let's see if I can figure out how to do this here. They want you to think about what's beyond what you actually see. Okay, we will let you do that. Yes, I think I want to do that. Fine with me. This is what happens when you put it on a different machine. Let's see if it really opens. I'm going to trust your machine, Adam. Here we go.
At your own risk.
At my own risk. All right. That's all right. There we go.
This is
A new
All right, so
psychological
there's only
syndrome.
music in the background, and I'm not hearing the music, so just watch the pictures.
the pictures
Oh, pictures aren't up, but they're on my machine, so why are they not? They're here. Technology, complex. Can you make that be up there?
be up there. I tried.
Okay, that's another form of causality that we actually do study, but it's about magic, but anyway. So, all right, I'm going to go back to my PowerPoint, and I will tell you that the commercial I was going to show you, I have some pictures from it. Why don't you bring my PowerPoint back up, Adam? Well, I have a 17-year-old son. He takes care of all of this for me. He's like, Mom, you study complexity. I'm like, yeah, but this is a computer. So, yeah, if you can just go back to the PowerPoint. That's excellent. But now you got to make it show.
Picky.
All right, so the commercial I was going to show you is a Nissan Leaf commercial. And it shows a polar bear walking down from the North Pole. Okay, use your imagination, right? Walking through this, down through the streets of New Jersey, and as the polar bear. All right, so now we have that back. So I do have some pictures of this, so I'll show you the pictures. This is what happens when the technology doesn't work. I've actually never had the film not work, so I don't know. All right, so if we can go down just a few. Okay, doesn't matter.
Does it matter dragging the picture to the right?
Okay, so let's just go. Let's just do this. Let's get back to where we were. And then you can go back to slideshow. So the polar bear is sitting on his melting ice. And, okay, that's okay. You just went back one. And he's walking through the streets. And he gets to this neighborhood in New Jersey, and he goes up to this fellow, and it looks like he's going to take him out, but he actually gives him a big hug. So what is, and if you can watch this online, it's really very sweet, but the idea here is that Nissan is saying, you're not going to think about the polar bear when you get up in the morning and you drive your car. So when you buy a car, think about that polar bear and make a sustainable choice. And they're bringing the cause and the effect into the same screen for you. They are sort of bypassing that problem of action at an attentional distance that we can't pay attention to and keep in mind every single day the things that are far away from us that we don't see, that are not in our attentional space. So putting them into the same attentional space in one big choice you make is to convince you that you really are paying attention to that polar bear every day when you get into your car. If it's a Nissan Leaf, they're saying to you. All right? That's a nudge. And that's a nudge when you buy a car. It's a big nudge. So when you're thinking about what you can do to help those around you, think about our world, think about ways to bring causes and effects into the same attentional space, to make people aware of them. Starbucks had a sign in our local Starbucks for a while, and it said next to the napkins, these napkins come from trees. It changed napkin using behavior. Just a nudge. So another big puzzle for us is non-obvious variables. If we can't see it, it's really hard to reason about it. And we do reason about things. If we see something happen, we don't allow for causeless effects. So if something happens and that effect is in our attentional frame, then we start to reason about what's causing it. And so, when a hurricane comes roaring through, when storms start becoming more drastic, when our world starts changing, people start turning their attention. So non-obvious variables is another complicating factor. Distributed causality is another one, and I actually think this is one that we have great promise to address because young people have witnessed the power of the internet, and they know that I can make things happen through my individual actions that have a bigger, broader, emergent outcome than myself. It's bigger than me. It's not easy to always think about distributed causation, however, because we don't always know whether our intentions at a lower level lead to emergent outcomes. If we're not aware of those emergent outcomes, we won't know. I was just driving to the supermarket. I wasn't trying to create climate change, right? So aligning intentionality at different levels is important, and helping people to see when intention at one level is unaligned with intention at another level is important. So that's another place where you can't see the covariation relationship because your part in the cause is not apparent to you. So the other part is that we tend to view intentional acts as more causal, more culpable. This goes back to preschool. It happened by accident. I didn't mean to do this to you. It was an accident. And that makes a lot of sense to us. So, but when somebody does something to us on purpose, we are much more likely to react and galvanize. Our politicians use this as a focusing event. So 9/11, lots of funding towards terrorism, when climate change has the potential to wreak much more havoc in our lives, and yet getting people to galvanize against it can be much, much harder. So it's really hard when we're looking back at ourselves, right, in distributed causality. We're looking at the role that we play. So in all of these, it's not enough to be able to reason in these particular ways. The two parts that are really difficult in cognitive science have to do with sensitivity and inclination. So noticing opportunities to change our behavior and then being inclined to do so. So I'm going to show you some things we do in K to 12 related to this, and then I'm going to just talk a little bit about ideas for how we might encourage sensitivity and inclination in the general population. This is for somebody who says she doesn't like computers, I actually work with people who really, really do. And we created a multi-user virtual environment. And you might say, well, I want the kids to really be out in nature. If this were really up, you'd hear the ducks quacking, you'd hear frogs, you'd hear sounds and things of outdoors. A lot of our schools, kids won't get there because their teachers won't be able to get them there, and they don't have the money to take the buses and get them there. So we use a multi-user virtual environment, but it has a lot of affordances that we're able to give them to support their reasoning about ecosystems as places that change over time, that are spatially large, that address some of the kinds of puzzles that I've been presenting to you. So they come into this world, they do what kids do, they chase the fish, they go under the water, they run around, and they start noticing things about the world. Eventually, they will start to notice that some things are changing. Often the kids don't notice until they see a big event. And the big event actually has to do with a fish die-off. This is a eutrophication scenario. And so once they discover the fish die-off, then they want to explain it. But in EcoMove, and in EcoXPT, a new version, they can travel back and forth in time to see the subtle changes they missed along the way. We want them to realize that reasoning about ecosystems involves reasoning about processes and steady states, not just short-sighted and not just about events. So they travel back and forth in time and see some of the things that they've missed. In order to solve the problem, they need to go quite far from the pond, which at first doesn't make sense to them, and they spend a lot of time in the pond. And eventually, they just keep finding clues that are pushing them further and further. And they start to realize that something far from the pond caused this to happen. It was a distributed action, it was a spatially distant action, and it starts to give them some information about what's going on. There is a lot of supporting structure for them to get there, so to be able to time travel, to collect information about dissolved oxygen, measurements and monitoring, noticing patterns over time, all very important to starting to realize not only what's happening in the science here, but how their reasoning, their cognition contributed to their first ideas and how they need to revise their cognition to understand what's really going on, the complexity of the system. And when we first do this with kids, a lot of times they say, I have the answer after one day. We're like, how do you know? What's your evidence? And we say, well, that might be a part of the story, but can you find anything that disconfirms that that's the whole story? And they're like, but what's the right answer? And we say, well, there's a best explanation, perhaps, based on the evidence, and they realize they're not there yet. And at the end, they sometimes still say, what was the right answer? And we say, well, scientists don't necessarily know what the right answer is, right? Because tomorrow might tell us something else. But we do know what a best explanation looks like if it's well-reasoned and has good evidence to support it. We also have a new version called EcoXPT. It's a broader world because we wanted them to really grapple with the complexity of the world. And we also gave them some epistemologically authentic experimentation. We worked a lot with ecosystem scientists. We interviewed them extensively. We asked, how do you find out about the complexity of the world when you can't do controlled experiments? And that lets them move from covariation to causation. We also give them mobile devices and send them out into the world. So how do you learn that this pertains to the world? So, the kids went out to Black Snook. They've gone to, areas around here. We have QR code triggers that let them see various things. So we're giving them just-in-time supports to notice things. This is more of EcoMobile. Lets them tag things and bring them into the classroom. One of the things that I really enjoyed about using EcoMobile is that we gave the kids virtual binoculars. So, and we've actually encouraged them to use the idea of virtual binoculars in other areas of their lives. But here, they could hold their device up while they were standing at Black Snook in Cambridge, and they were able to see images from Hobbs Brook Reservoir, which is up right along 128, and it's on the Lincoln-Lexington line. They saw that, and they said, wait, what is that? That's a highway? That's next to our water? And they got all up in arms about it. They started doing a lot of research about, there was a salt depot out here. They wanted to know if that pollution could get into their water. They started saying, now we need to do water tests of why this looks like this. We also give them another one that has to do with time traveling, and we use that as a tool as well. So looking beyond, considering scale, finding the hidden, starting to ask those questions. And we can tell in EcoXPT and in EcoMobile what they're attending to. What are they paying attention to? What are they missing? And that lets us know, are we developing sensitivity and are we developing the inclination? Another thing that we do with them comes from the work of my doctoral advisor from, the 1980s, Dr. Larry Kohlberg. He was considered the father of moral development. Yes, really wonderful person. And he developed an idea called moral musical chairs. And we engage in this game with kids. So how does it work? So learners consider what perspectives might relate to a situation. They gather information, and then they play moral musical chairs to consider each perspective, but they have to imagine that they could be anyone in the scenario. So what if you lived on that island that people have to leave because of the rise in sea level? So those people are in the chairs, but the role is on the chair. So you could be that person and have to debate from that perspective. So it's a way of pushing them to think about different perspectives. So what perspective do I hold? What are some other perspectives? And how do I step out of my own shoes? So these are things we do with K to 12. And they definitely encourage ability. Some focus on sensitivity and inclination. But one of the questions that I ask, and that's really the long view, K to 12. But one of the questions that I ask is, how can we get the masses to start to revise the way that they think? If all of us in this room compost, we do all the most sustainable things we can do, it's not enough. So how do we get other people to do these things? So what if when you went into Whole Foods or whatever your local supermarket was, you had an app on your phone, and every time you made a sustainable choice, you got a little bit of money back. You got some points. And that mattered at the register. People used to cut coupons. I think they'll use an app on their phone, right? So how do we encourage sensitivity? Your phone makes a noise because you're standing in front of something where you have the opportunity to make a sustainable choice. Ability, it tells you what choice to make. Inclination, it rewards you at the register if you do it. Smart thermostats are like this. They take away our having, we're out the door in the morning and we're not thinking about, did I turn down the thermostat? Did I do this? Did I da-da-da-da-da? It happens for us. It starts to, and they're decisions that get made once. My Starbucks example, I like that one. So there's also making the fault in emergent outcomes more visible. That, and it starts, with K to 12, it starts in the cafeteria with things they think they're not responsible for. So the cafeteria is getting noisier and noisier and noisier, and it's escalating, and there's this emergent outcome as they all start to speak louder to be heard over the person next to them. And we've done a lot of research on how these patterns happen and how kids understand them. And, they'll tell you, it was the fault of him sitting next to me. They don't see their distributed causal action. So helping them understand what happened really in the cafeteria, they know they have control over that, because if you've ever been like a new young teacher standing in front of a class trying to get them to be quiet, they know they control whether they get quiet or not. They know they can get each other to be quiet. But how do you help them connect that to behaviors that are bigger and broader and that impact us in such major ways like climate awareness in climate change. So the question I put out to you is, what else? What else could we design as these nudges that can live in everyday space, that get people to attend, help them know what to do, and create the inclination in everyday spaces that bypass, we're not going to radically change the human brain. We can start to rewire some of the pathways. Default pathways tend to be very well ingrained, and it takes, lots of pushing out of those pathways to start to create new pathways. We can do that, and that's what we're trying to do in K-12. But what can we do in the everyday environment for the people that we can't reach to help them do these kinds of things? So we have a website with some of our materials. This is some of our causal learning in the classroom materials. We have a whole eco-learn. There's actually 2 more projects where we're using virtual reality. We're using augmented reality as well. And we actually have some folks in China are creating glasses where they can move around. Yeah.
A lot of this assumes that this is all about individual responsibility as opposed to corporate responsibility and sort of power dynamics. And I'm wondering how, what you're presenting fits with that.
With corporate
Because I
responsibility?
think there's a real problem with continuing to get people to think of climate change as individual behavioral issue versus
Yeah.
a systemic.
So she's asking, what's the corporate responsibility in this, and how do you, go ahead.
A lot of this assumes that climate change and a lot of the social ills that we see are connected to individual responsibility as opposed to power and, some people having more power than others and making decisions that addresses their interests at the expense of others, which is a really different frame. And I think, to me, it's really dangerous to keep continuing to get people to think that we're going to solve the climate crisis through individual behavior change.
To me, it's really dangerous to assume that somebody in power is going to change it for us. We have the power to make choices in what we buy and what we purchase and how we push on our legislators. We may be feeling very unempowered right now, given the president who's in the White House. I know an awful lot of people who didn't go and vote. And so I'm going to say that if we say it's one or we say it's the other, I think that's the dangerous position to take. We live on this planet, and so we need to find ways to change people's behavior every single day. We're not going to knock down and rebuild entire cities. I mean, that would be lovely. We don't have a blank slate. So I think we do need to incentivize individuals to behave in the ways that they can. So I drove a Prius here this morning, and I work from home all but usually 1 to 2 days a week. I have a big old car because I have 2 adopted kids and then I have twins. So, and it sits in the garage. And that's a choice that I make every day. I decide which car am I taking, how do I, it's 12 years old, it barely runs too.
And
so.
that's really important, but ultimately the fossil fuel industry is keeping us where we are, right? And so we can all buy Priuses and it still won't make a difference. We need to change the rules of the game. So, this is great, but I think, building political power to change the rules, and sort of getting people to see that connection, because I think a lot of people actually feel really powerless because they know that, buying Prius, or they can't afford a Prius, right? There are a lot of people that are locked into using fossil fuels.
I don't know. Okay, all right, fine. So it may be that they can't afford a Prius, but at that point, a low-end Prius is, like as low as they go. So, but what I guess what I want to say is I don't think dichotomizing it as it's this or it's that is going to serve us well at all. I think we need to adopt both perspectives, and we need to really go in both directions. It's not about them. But Lynn, did you want to? You want me to stop?
Well,
It's fine.
yeah, we
I'm gonna put
kind
this
of
up.
started a spontaneous Q&A,
Yeah.
and that's a really good thing to do, and I
Yeah.
think there's a lot of sense that we need to do that.
Yeah.
We do have another speaker this morning.